Solving log equations is very similar to solving exponentials. Our first step is we try to isolate the log term. Now notice something, the word try. We're not always going to be able to isolate the log term, but for these first simple couple examples, we will be. So try to isolate the long term. Second step, it's probably the weird one, new word. We're going to try to exponentiate. E-X-P-O-N-E-N-T-I-A-T-E. We're going to exponentiate both sides, which pretty much just means make both sides the exponent of the base, because then we can get them to reduce. And lastly, we're going to solve whatever the resulting equation happens to be. It might be linear, which is probably the easiest. It might be quadratic, or it could be rational. And we'll talk about what that means in a little bit. We'll come back to the food for thought in a second. So looking at our first example, log of 4x equals 2. First step is isolate, which I'm done. Second step, I need to realize, I'm going to rewrite it as log base 4x equals 2. This is where I need to exponentiate. So what I'm going to do is make each side a power of the base, which was 10. So I'm going to make it 10 to the log base 10 of 4x equals 10. Oh, try to make that go away. 10 squared. So what happens is 10 to the log base 10 goes away, and I'm left with just 4x on that side. And on the right hand side, 10 squared equals 100. So in this case, I end up with x equals 25. That is my possible solution to my logarithm. Now, food for thought, going back up here. Remember, the domain of the log function is 0 to infinity. So you must check to see if the solution is a solution and make sure it is not extra. And we can just do this visually. So for my check, I'm going to come right back up here and I'm going to look at the inside of my log term. Now I'm going to notice if I put a 25 in for x, then I keep everything positive and I'm good to go. So this is my solution, x equals 25. On to my second example. This one's a little bit tougher because in this one, I have to actually isolate the log term. So two steps, I need to subtract 18 and divide by 2. When I do both of those things, I get log base 2 of x minus 4 equals, let's see, 21 minus 18 is 3, divided by 2 is 1.5. And then I need to exponentiate. Since my base is 2, I'm going to make each side a power of 2, because 2 to the log base 2 goes away, and I'm left with just x minus 4 on the left-hand side. And then on the right-hand side, if I do a little bit of math, I know that 2 to the 1.5 power is 2.828, approximately. And then just solve, add 4 to both sides, so x equals 6.828. And that's my answer. Or as I should say, that's my possible answer. So I'm going to come back here and I'm going to check him. I'm going to look right in there and just visually confirm with myself that if I plug in 6.8, I don't make it negative. And that's good, so he is my solution. Stepping down to the next example, example 3, I need to isolate my log term. So I add 14 to both sides. That's a 41. Go ahead and erase that. 14. There we go. So I get negative 3 natural log of 4x minus 2 equals, that's going to be negative 14. Continue isolating. Divide by negative 3. Divide by negative 3. So I'm going to end up with 4x minus 2, the natural log still there, equals whatever 14 divided by 3 is. I'll use my calculator quick. 14 divided by 3 is 4.667. Now, as soon as I see a natural log, I'm automatically thinking e. So when I exponentiate, I'm going to take and raise e to the power of both sides. I know that e to the natural log goes away. That leaves me with 4x minus 2 equals, and then I have to take e to the 4.6 power. So e raised to the 4.6 is going to be around 99.48. I might have rounded a little bit there, but you get the idea. Let's say 0.484. Again, that's probably a little rounded in the wrong way, but it gets you the right idea. And lastly, I add 2, and then I divide by 4, and my final answer should be around 25.37. Again, that's probably off in terms of some rounding, but there's my answer. So I look at that and I say, okay, is that a possible answer? I'm going to come back up here. I'm going to look at it and visually confirm that if I plug 25 in, I end up with a positive number. So I am good to go. There's no problem there. So here's my solution. Lastly, example 4. If I take log base 433 and log base 433, I can think of this as two ways. The easiest way is just to realize if log equals log, I'm not going to be able to isolate, but I can go ahead and just take 3x minus 1, 3x minus 1 equals x plus 7. The insides have to be equal. Or if you think of it in terms of exponentiation, make 433 the base of each side, and those both cancel out, and I'm left with what I have originally, 3x minus 1 equals x plus 7. So if I solve this, I end up getting 2x equals 8. So solve it, x equals 4. And I have to be slightly careful here because there's two places I need to look at. I need to make sure that it makes each of these values positive. If I plug in a 4, it obviously does. So my final answer here is x equals